Good day, folks. Welcome to Pride's Mind Academy, where we bring brilliance to every lesson. Now, let's look at question two under organic chemistry. Yes, organic chemistry. Now, question two, it is specifically called nomenclature. All right. Now we have letters. The letters A to H in the below represents 8 organic compounds. Okay. Now, before I look at the questions with this type of questions now, nomenclature, the table form, what I like to do it is I like to analyze everything in the table just before I can get into answering questions. Now, I find it beneficial because sometimes most of the answers that I get from the table, even without looking at the questions, normally appear. Okay, now let's try the strategy now. Butan 2 all, I know this is an alcohol. Okay, first thing first, I can see it is an alcohol, and an alcohol, it is under the group of what? A hydroxyl group. Again, it is the hydroxyl group. Again, now how do I draw its structure? Butan to all, it means now all this, the alcohol, it is in position number 2. 1, 2, 3, 4. Now the functional group, which is alcohol, it is in position number 2. So I have this as my OH. The rest I know it is just hydrogens. I don't draw them for now. Okay. Now, if they talk about it only has a positional isomer. If they were to talk about the positional isomer of this one, the only time you can change this, it is when you take this from here to there, so that it becomes butan 1 all. Because when you take it to here, can you see that it is still butan 2 all? Because 1, 2. When you count from this one, 1, 2. Okay. So this is just the what? The isomer, positional isomer. Okay. 3-ethyl pent 1 in. This is the aldehyde. Sorry, I'm lying. The alkyne, right? This is the alkyne, and I know it is unsaturated. Unsaturated. It has triple bonds, right? Now, how do I draw this? Pent. Pent means what? 3. Okay. So it is 3-ethyl. Sorry. Pent it is 5. I'm lying. Pent it is 5. 1, 2, 3, 4, 5. I'm told that at position number 1, from wherever I start counting, I have what? 3 bonds. 3 bonds. Remember, wine, it is 3 bonds. Okay. So it means starting from to count 1, here I have 3 bonds. Okay. Also in carbon number 3, I have an ethyl group. Okay. Alkyl group with an ethyl. Eth means what? 2 carbons there, like this, in position number 3. If this, I start counting this 1, 2, 3. So it means somewhere here I have CH3, CH2, like that. I have a branch like that there again. But I want you to see something. I'm only left with 1 carbon here that can fit. This one is already full. Can you see? C, it is 1, 2, 3, 4. So remember, carbon can only take 4 again. Do not say here and here. No, you are lying. Then here it is 1, 2, 3. Then how can I get the rest? The 4, it will come here. 1, 2, 1, 2, 3. Okay. Yes. Oh, sorry. Now when I come to this one, CH3, CH2, CH double bond, CH3, CH2, where can I start counting? I should start counting from where this one, it is the lowest. My double bond is the lowest. Let's see. 1, 2, 3. Then I'm gonna come here. 4. Longest chain, 5, 6. Okay. If I start counting from here, it is 1, 2, 3, 4. Well, it's still the same. Okay. Even if and I start counting here, 1, 2, 3. The double bond is still connected to the double. Now this is my longest chain. This one. This is my longest chain. When I start counting, you can, if you were to say, if you did like this, if you said 4, 5, can you see that this gives us a short, but we want that gives us a higher what? Higher a longest chain. Again, longest chain, not higher longest chain, which is 4, 5, 6. Then these will be our branch. These are our branch. Okay. CH3, CH, this is, let me see, any special part? No, nothing special. Now, the most tricky part about naming the haloalkyne, or halohalides, it is now in terms of choosing which one to prioritize, whether it's the Cl or the CH3. In this case, you do not prioritize either the Cl or the CH3, the branch or the Cl. Now you count the one that gives you the least number of, like I'll show you. Here, if I start counting here, it is 1, 2, 3, 4, 5, and 6. Why did I opt from saying 1, 2, 3? Can you see I'm left with 3? And how many are there? Carbons. So we don't want that. Okay? I could have said 1, 2, 3, 4, 5. But can you see this is 6? I can still do more. 4, 5, 6, 7, 6 here again. Even if I opted to come here, this one I can't come here because it is a CL again. Okay, so now this is 1, 2, 3, 4, 5, 6. This is a hex. Okay, now I should see how do I name this now, because I see in carbon number 2 I have CH3, in carbon number 2 I have Cl2, in the last carbon, which is carbon number 5, or not the last, I have Cl2. So which one do I prioritize? I want you to see this. When you let's first prioritize the branch. Okay, can you see that this is our branch, this is our substituent? Now let's start prioritizing the branch. We're gonna start here, right? It's gonna be 1, 2, 3, 4. Oh, we also have a branch here. Okay, 1, 2. The branch is like this. Let me say it's gonna be 1, 2, 3, 4, 5, 6, right? So it is in carbon number 2. Okay. But if you wanted to prioritize this branch, can you see this 1, 2, 3? So we can't go that one because it gives CH3 the longest number. Okay, so what we want that such that it is on the carbon with the lowest number, which is carbon number 2 in this case. The CH3 that we're going to prioritize first is this one that gives us the least number. Okay, let's say if you tried to prioritize Cl. When you prioritize Cl from here, can you see that it is carbon number 2? Similarly, when you prioritize Cl from this one, if you count 1, 2 from here, can you see that is still on carbon number 2 also? So now it means the deciding factor now becomes what? CH3. Okay, so CH3, it is in carbon number 2 from here and carbon number 3 from here. So it means we'll prioritize from this side. Okay, yes. Then we have CH3C. This part means you have a branch like this, CH3, then C, you have a branch of how many? Two branches. Like if you have CH3, 2, it means now you have 2 CH3s. But the question is, why can't I do them like this? Let's say this is the one. Why can't I do them like this and say this? If you do this as a branch, this one, you can see that the carbons that you have, it is 1, 2, 3, 4, 5. Okay. So it's gonna be like that. Then CH, take pitangai 2, we have CH like that, 2, CH2. Okay, so if you have CH2, sorry, so CH2 like this, it cannot be a branch because look, I want you to see something. Let me do a branch with different color. See, this is 3. Oh, sorry, this is gonna be 2, but this is 1, 2, 3, 4, 5. Can you see now here we have 4 hydrogens? So if even if I were to try like this and say, see, this was gonna be 3 and this was gonna be 3, which is 6. So it means now this one repeats itself. So they tell you that CH2 repeats itself like this. CH2 like H, H, C, H, H, then CH3. I want you to see that. Can you see that? Now it falls under which group? This is an alkane, right? This is just an alkane. CH3, CH2, 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 CHO. Let me try to draw that. Butane 1 all. Can you see that this is now this is an alcohol. But remember I said for butane 2 all, the positional isome might be in position 1. So it means this might be the positional isome of 1 of A, because they are all alcohol and hydroxyl group, but now it is a what? It is butane 1 all, that one was butane 2 all. So this is a positional isome. Then here we have, okay, let's come here. D, we have CH3, CH2, 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 CH, like this. CH3, CH2, 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 CHO, like O. But do you agree with me that O will have a double bond? Because if I just do O with single bond, it will be carbon. This carbon will have three bonds, which is one, two, three, and it's sorry, one, two, three, and the carbon should have four bonds of maximum, right? So here it will be double bond again. So it means now if I redraw this like this is a ketone, sorry, an aldehyde. Why am I saying this is an aldehyde? Because now the positional group, the double bond O, it is at the terminal. Remember the difference between aldehyde. Which one was I drawing? Aldehyde. The difference between aldehyde and ketone is that ketone will have the double bond O at the middle. Again, at the middle of the carbon that's between other carbons, basically. But this one, it is always at the terminal. So this is why we call it aldehyde. Again, and aldehyde, it is a functional isomer of a ketone. Why am I saying it is a functional isomer of a ketone? Because now ketone will look something like exactly almost like that, but instead it will have double bond there. Eh, sorry, double bond O here. So can you see? You cannot say it is positional isomer because it changed its position from number one maybe to number two. The minute you change the position of double bond O for the aldehyde, it is no longer called an aldehyde, it is a ketone. So hence we cannot have no positional isomer for this one, no positional isomer. Okay, because the minute you change the position of this one, it becomes a ketone, so it becomes another function. So hence we call it a what? A functional isomer. I want to believe you are following. This one, it is CH3. Let me start to count, maybe one, two, three. So this is something like CH3, C, CH3, a branch, C double bond O, H. Okay, so now also this one, it is also an aldehyde. Why? Because can you see the double bond H? It is at the last carbon, which you call the terminal carbon. Yes, so this is also an aldehyde. But now you should be curious. If I'm having two aldehyde now, if this one D was an aldehyde and this one is an aldehyde, let me count the number of a carbons here. We have 1, 2, 3, 4, 5. Here we have 1, 2, 3, but two of them are called branches. Okay, so now this one, it is what we call we have positional isomer, we have functional isomer, we have um structural isomer, chain isomer, sorry, chain isomer. Okay, so this one will be the chain isomer. Why am I saying it's going to be the chain isomer of D? Because now, instead of having 5 long chain carbons like D, instead your net is having what? It is having 3, whereas 2 of them are the branch. Okay, and for the chain isomer to occur, they should have the exact number of carbons. Okay, can you see that here for D it is 1, 2, 3, 4, 5? Similarly, for H, it is 1, 2, 3, 4, 5. Okay, without considering the longest chain for now. Okay. So now, yes, I think we're in a position of answering the questions. I think I spent 10 minutes explaining this, even more. Okay, let's be quick now. I have only 15 minutes left. Define a hydrocarbon. Remember, a hydrocarbon, it is a compound that consists of hydrogen and carbon atoms only. Okay, a compound that consists of hydrogen and carbon atoms only. That's hydrocarbon. 2.2.1. Write down the letters for two compounds that are unsaturated. Two compounds that are unsaturated. So we want for the unsaturated, it can only occur between alkene and alkyne. So the first one I see, it is C. Remember, we said it is unsaturated, it is alkyne. Okay, C. And the other one that I can look for, I have an alkane here. I want you to look for something here. Can you see here? It has double bond here again. So this is an alkene also. E, it is an alkene, it has double bond. C and E. C and E are the most correct answer. Okay? C and E are the most correct answer. Now 2.2.2 says uh, two compounds that are chain isomers. Chain isomers, chain isomers. Remember we discussed that chain isomer. I said A sheet is a chain isomer of D. Okay, so H and D and H are chain isomers. Can you see now this is helping? D and H are chain isomers. Identify a secondary alcohol. A secondary alcohol will have an alcohol like like this. Can you see? It is surrounded by two carbons. So the carbon that is bonded to the OH should be bonded to two carbons, two other carbons. Okay, that is what we call a secondary. If we had a C like this, can you see that it was surrounded by three? Now it is a tertiary. Okay, so can you look at that? If I look here, the carbon bonded to the the carbon bonded to the OH, in this case, this part, can you see that it is bonded to this? What this is directly bonded to? It is bonded to this one and this one, not this one. This one does not make any contact with the carbon that is bonded to C. Okay, do not make that mistake. So if this is the king, it is bonded to what? To 1 and 2. So A is the most correct answer. For 1 mark, A is the correct answer. 2.3.1 structural formula of the functional isomer of compound D. D, where is D? D here. The structural formula of the functional isomer. Remember I said it is a functional isomer. It is a functional isomer of what? Where is that structure? D. Here it is. Here it is. Here it is. This is D. Okay. If this is D, how can I draw the structure of its functional isomer? Structural formula again of the functional isomer of D. Now remember I said you have to change the position there, because if you change the position, it does not become a positional isomer because it changes the name of the name. It no longer becomes an aldehyde, it becomes a ketone. So from that I can say, I can just take it. It has how many carbons? 1, 2, 3, 4, 5. I get like this. It has carbons like this. 1, 2, 3, 4, 5. I get, and I know this is my hydrogen. You miss one hydrogen, you are out. You lose a mark. Okay. But now instead of putting the oxygen here, we're gonna put it on the next carbon, like that. Can you see that I'm not putting any hydrogen here? Why? Because this carbon already has 4 bonds. 1, 2, 3, 4. Okay. So this is what I was required to draw. Okay. You can put it anywhere. Here, on this carbon here, on this carbon here. But as long as it is not in carbon number 1, this is what causes this to become a ketone. I believe you are following. I strongly believe you are following. Okay. So let's try to take that quickly as we can. I repeat, you miss a bond, you are out. Oh, okay, it's fine. Let's just leave this. You leave a bond, you are out. Okay. General formula of the homologous series to which B belongs. What is B? What is B? B. Okay. Where is B? I said B. It is alkane. Okay. Remember alkane. It is just, where is it? CnH2n plus 1. Okay. From alkane to alkene, it decreases like this. It's gonna be CnH, sorry, plus 2. Plus 2. Okay, this is alkane. When you go to alkene, you're gonna subtract 2, so it becomes CnH2n. Okay, when you go to alkyne, we subtract 2 again, it's gonna be CnH2n. Remember, this is plus 0, so when you subtract 2, it's gonna be minus 2. So this is kene, this is cane, this is kyne. Okay, this is the strategy that you need to know from alkane to alkene to alkyne, you subtract 2. Okay, I believe I answered that. Structural formula, this one is CnH2n plus 2. Structural formula of compound C. Structural formula of compound C, 3-ethyl pent 1 ion. The longest chain, it is 5. 1, 2, 3, 4, 5. Now let's check. They said 3-ethyl. Okay, let's start with the functional group, which is 1 ion. So carbon number 1, we have triple bond. Okay, so I can add here. And carbon number 3, we have ethyl group, because we have 3-ethyl. Okay, so if this is 1, 2, 3, 4, 5, so this is number 3. So I'll have ethyl like that, like that. Okay, then I'll fill up other hydrogens like so. I want you to see something here. I do not add hydrogen here. I do not add hydrogen there. Why? Because when you look at this carbon, the number of bonds, it is already 1, 2, 3, 4. It is enough. When I look at this second carbon, why do I not add any hydrogen? Because it is 1, 2, 3 plus 4. It is enough. Okay, so here it is 1, 1. I can just add. Okay, please count. Counting is very important. Write down the IUPAC name of compound E. Compound E, IUPAC name of compound E. Let's see that. So when we name, remember we said we start from wherever. Let's say this is 1, 2, 3, 4, 5, 6. When we name that, we have hex. We already have hex. Again, we have hex in our hand. And now we have a double bond at carbon number 3. So it means we have, we also have an ethyl on carbon number 4. Why am I saying it is an ethyl? Because it is CH2, CH3. So it means I have 3 ethyl, because this is the ethyl group, the branch. Okay, so I have 3 ethyl. When I start with the branch again. 3 hyphen ethyl. Remember, between a name, a number, and a letter, it is a hyphen. 3 ethyl. Then I look at the longest chain. Longest chain, I said it is what? It is hex, 6. 3 ethyl, hex. I do not need a hyphen because it's still letters. Hex, hyphen. Functional group, it is on carbon number 3. Carbon number 3, it is a carbon number 3. And now it is what? That functional group, it is an alkene in. This is the name. 3-ethyl hex 3 in. Then let's look at the last one. Oh, sorry, the second one, 2.4.2, the name of G. The name of G, remember I said we're going to start counting from here. So this is going to be, where are our branches? Oh, okay, this thing, I think it has shifted. This was our branch, our second branch. This our CL and our CL. So when we name this, remember we're going to start with the one that, remember it is 1, 2. So it's either we start with the methyl. How many methyl? We have methyl in carbon number 2 and methyl in carbon number 4. And this one we have Cl in carbon number 2. We have Cl in carbon number 6. So now remember instead we're going to start counting from here. So between methyl and chloro, between meth and chloro, which letter comes first? It is C again. So we're going to say all the chloros, it is 2 and 5. So this is carbon number 5. This has shifted. You can count again. This is carbon number 5. This is going to be 2, 5 dichloro. For 2 chloro, we have say dichloro, then hyphen, then we count the methyl group. It is carbon number 2 and carbon number 4. So it is 2.4 dimethyl. Dimethyl what? Dimethyl what? Hexane. Longest chain, it is 6. Hexane. Dimethyl hexane. Compound name of H. It is what? It is 1. When I start counting from maybe here, from here, where the functional group it is situated, 1, 2, 3. Because even if I go here, it is 3. Even if I go here, it is 3. So this is the structure that I draw. Is gonna be 1, 2, 3. So it's gonna be, Remember, this is an aldehyde. So for the aldehyde, you do not name the position of the functional group. So it's going to be prop 2 dimethyl, 2.2 dimethyl. Why? Because the meth are on carbon number 2, both of them. Okay, so it is 2.2 dimethyl, then methyl prop, which is for 3, okay, prop, then what? Remember, for aldehyde, al, so it should end with propanal. So it is 2.2 dimethyl propanal. No need for naming the functional isomer. It is in carbon number. It is always in carbon number 1. So it is dimethyl propanal. Unlike ketone you should say 2.2, sorry, hyphen dimethyl, let's say prop, and it ends with a ketone own, like this. So it's gonna be a number and own, then propan 2 own, like that. Okay, the only time you do not say propan, like propan something own, it is when you deal with alkane. Okay, but once you start naming more ester, ketone and what, you need this propan. Okay, because such that it can be propanone at the end. Now, compound B undergoes combustion using molecular formula. I do not want anyone getting less than 2 here, because for a combustion, it is a reaction of whatever alkane with carbon dioxide and forms what? Sorry, not with it reacts with oxygen, excess oxygen, and forms what? Carbon dioxide. So, and water. So it is a reaction of B. What is B? Alkane. So B, when we use a molecular formula, let's count the number of carbons. 1, 2, 3, 4, 5, 6, 7. Because here, can you see there are 2 carbons here? So you count 2. Even here, there are 2 carbons, you count 2. So we have 7. So if it's 7, I know the general formula says CnH2n plus 2. So it is plus 16. C7H16. You can count also the hydrogens, okay? C7H16. Just saying it reacts with O2 to form carbon dioxide and water, you have 2 marks. Okay? Just saying that you have 2 marks. You haven't balanced, you haven't done anything. You have already 2 marks. Then when you balance now, the amount of carbon that needs to be balanced, there are 7 in here. It means we have to add 7. Okay? With the last part you want to balance it is oxygen. Okay, balance C and H. Now H here, there are 16 here, there are 2. It means we have to add 8 here so that it becomes 16. Now you can count oxygen. How many oxygen are there in this side? It is 7 multiplied by 2, it is 14, plus 8 multiplied by 1, it is 8. Then in total it is how much? 14. This is 22. Then what should I add to 22? What should I multiply 2 with to give me 22? You can say 22 divided by 2. It is 11. This is your balanced equation. Now the first 3 marks. The first mark, it is this one. Okay. The second mark, it is the correct molecular formula of inorganic reactants and products. All of these, it is correct. 1 mark. Then the last mark, it is when it is balanced. That's where you get your 3 marks. So you can get a 2 here out of 3 if you maybe forgot to balance. Okay, yes. So thank you. That's all. Let's meet on question 3, physical properties. If I did any mistake, please leave that on the comment section. Thank you.